Hello, Caymans. Mr. Eicher here. This is part 2 of a 3-part lesson. We're starting with reviewing conic sections, and I wanted to take some time to review completing the square. And then the third part of this video series will be applications of conics. So we'll do these 4 questions that you see on the screen right now. And your try this on Schoology will be the hearted parts of the questions. So I'm going to walk through completing the square for each one, and then I'd like you to find the details of the conic sections that I ask you for. So let's get started. So number 1, we're going to complete the square to put the conic into standard conic form. And a couple observations. The first thing I notice is we have an x squared and a y squared. So we probably should collect the x's, if I actually highlight the right one, collect the x's, there we go, and then collect the y's, and then we're going to complete the square. So we would have x squared plus 8x plus blank plus y squared plus 2y plus blank, and I'm going to move the 8 to the other side by subtracting 8 from both sides. And really helpful strategy is to put plus blank so you don't forget to add the same amount to the right side that you've added to the left side. So if you'd like to pause the video and see, do you remember how to complete the square for the x's and then for the y's? The formula to complete the square is b over 2 squared, where our b in the first case is 8, so 8 over 2 is 4, squared is 16. We're going to add 16 to both sides. And then b in the next one is 2, so we divide by 2 and square it, so it would be a 1. Then we can simplify. The reason why that we chose 16 here is so that when we factor it, we would get an x plus 4 squared. We've made it a perfect square trinomial, and that means we can factor it into a binomial squared. And then the same thing with the y coordinates. So we have y plus 1 squared equals, looks like 9. So this would be a circle, equation of a circle. If we divided both sides by 9, I'll do that in my fancy red here. If we divide both sides by 9, then we would get a 1 here. So you might think it's an ellipse, but anytime these two denominators are the same and you're adding, then really that ellipse is a special type of ellipse called a circle. So we'll just leave the equation like that. What I'd like you to do as a try this is this heart down here. I'd like you to state the center of the circle, and then tell me what the radius of the circle is. And you'll do that on Schoology, but if you'd like to do that right now, you'll save yourself some time. And then you could graph the equation of the circle. Let's look at number 2 now. Again, we're going to complete the square. And probably the most important observation is notice we only have one squared term. Having only one squared term means the conic section is going to be a parabola. That's the only conic section that we have with only one squared term. Looking back up here, hyperbola has squared and a squared, ellipse has a squared and a square, circle does, but this one, the parabola, is the only one that has only one squared term. The other does not have a squared on it. It's just raised to the 1. So let's collect the common variables. And the other stuff, we're going to move to the other side of the equation. We're going to move that 8y, and we're going to move the 4. So that would give us x squared plus 4x plus blank on the left. And adding 8y to both sides and adding 4 to both sides, we get that. Now we complete the square. Our b value is 4. If you'd like, you can pause the video, see if you can write the conic form for this parabola. So you should have added 4 to both sides. So that would give us, we can factor on the left to be x plus 2 squared. And on the right side of the equation, we'd have 8y plus 8. Now we just need to take a greatest common factor out of the right. So our final answer would be x plus 2 squared equals 8 times y plus 1. So this is our standard conic form for the parabola, and what I would like you to do, and you could do it right now if you'd like, is to state the vertex, the focus, and the directrix for this parabola, and that will be on a try this for you on Schoology. And then you can sketch a graph of the parabola. Let's look at number 3. Number 3, we have multiple squared terms. So we have a 9x squared and a 36. We have a 16y squared and a 32y. So let's collect the x's together and the y's together. Now when we collect the x's, we have a leading coefficient on the x's, and we have a leading coefficient on the y's. That's the first time in this video that we've seen that. So we're going to have to factor a 9 out of both of those x terms. So if we do that, that would be a 9, and we're left with an x squared plus 4x plus blank. Again, I took a 9 out of this term and that term. 36 divided by 9 is 4. And then since y squared has a 16 leading coefficient, we need to factor 16 out of those green highlighted y terms. So that would be 16 factored out. We have left y squared plus 2y plus blank. And the 92 is in the way, so I'm going to add 92 to both sides. And good strategy to put plus blank to make sure you don't forget those. Now, when we complete the square, we should have a 4 here. But what value do I add to the right side? Be really careful here. 2 common mistakes. Number 1, students don't add anything. Or number 2, they only add 4. Really, the left side of the equation has increased not just by 4, but it's increased by 36, 9 times 4. So we need to add 36 to the right side of the equation. And then here we would be adding a 1. And I'll ask you, do you know, can you think, can you visualize the number in your head that you're going to be adding to the right side of the equation? It's not a 1, but it would be a 16 times 1, which is 16. Now we have an equation that looks like this, 9. We can factor to have x plus 2 squared. We have a 16, which factors to be y plus 1 squared. And we have 92 plus 36 plus 16 is 144. Now we're almost in standard conic form. The problem is, again, we have these coefficients here, this 9 and this 16. So what we do is we're going to divide both sides by that 144, because remember back up here on the previous video when we were talking about ellipses and hyperbolas, we said you really need to make sure that it's set equal to 1 for each of these conic sections. And what we have here is not set equal to 1, it's set equal to 144. So we should divide each term by 144. Now just to make sure you get the right number, if you actually did 9 divided by 144 in your calculator, you're going to get a fraction, or some decimal. 9 divided by 144 is 0.625, 0.0625. We don't want that, so actually I'd encourage you just to divide it in the other order, and then it'll make it a little easier to tell what the number is. If you do 144 divided by 9, I know that's kind of opposite of what you'd expect, but you get a whole number, and that whole number is in the denominator. So we have x plus 2 squared. We divide by that whole number we got of 16. That's 144 divided by 9 is 16. And we could do the same thing on the next term, y plus 1 squared. If we did 144 divided by 16 in that order, that's going to give us a 9 in the denominator. It's really a 1/9 that we're multiplying by, but just so you can see the whole number, it would be a 9 in the denominator. And 144 over 144 is 1. So this is our standard conic section. And it looks like, since we have a plus here, it looks like this would be an ellipse. And we do have the bigger denominator out in front, so that's going to be a horizontal ellipse. What I'd like you to do right now, if you'd like, is to tell me what's the length of the major axis, the length of the minor axis, and then what is the value of C that you'd use to find the foci. And then you can graph the ellipse once you have that information. Last one we'll talk about in this video is number 4. And number 4 is a similar process that we just did in number 3. So number 4, we should collect the x, variables, collect the y variables, and we're going to move this 124 to the other side. Again, note that we have a leading coefficient with x squared, so we're going to factor a 9. Not a 9x, you might be tempted to pull a 9x, but just, we're only factoring the constant. So we have a 9, and you have x squared plus 4x plus blank. And then same thing, we have a leading coefficient of 16, and it's a negative 16. So we're going to take a negative 16 out. We're left with y squared plus, because we're taking a negative 32 becomes positive 2y plus blank, and that equals positive 124. Remember, it's a helpful tip to do plus blank, so you don't forget to add those values. I'd encourage you to pause the video and see if you can add the correct values to the right side of the equation. Okay, we would have a 4, adding 36 over here. We would add a 1, and we'd add a negative 16 over here. So we would get 9x plus 2 squared minus 16, y plus 1 squared equals, and this would be a nice 144 again, like we had last time. This is almost done, but like we said last time, we need to make sure we don't have a leading coefficient, so we need to divide each term to make sure that on the right side it equals 1. So if we divide by 144 to each term, we would have x plus 2 squared, we'd have a y plus 1 squared, and that's equal to 1 now. And see if you can figure out what the correct denominators are if you'd like to pause the video. And the denominators are 16 and 9. And notice that we have a difference. So that tells me that this standard conic form is a hyperbola. So what I'd like you to do, or what you'll do later as you try this, I'd like you to state the center of the hyperbola. I'd like you to make your box, and then state the equations of the asymptotes for this hyperbola. Thank you for watching this video. I hope seeing these 4 examples of completing the square with conic sections was really helpful. And in the last part of this video series, we'll look at some applications of conic sections. Have a great day. Thanks for watching.